Hello YouTube, this is my channel. I am Random, and in this video or in this channel I am going to talk about some very interesting things that is related to engineering, and one of the lovable topics to me, or one of my favorite topic, is discrete choice modeling. Now, discrete choice modeling is required by engineers that are from transportation engineering field and also by students from economics. This is a very, very famous theorem or a model that actually helps us to actually determine uh, whether a person will not choose something over another thing. Now, I'm going to try to keep discrete choice modeling very simply in this video. I don't want to get into very details of it and the complexity of discrete choice modeling, but I want to give you the idea that how discrete choice modeling is very much tangible to us in real life. Now, these are the topics, or these are the things that I want to talk about in this video. And I'm not gonna go through them like in academics, like, yeah, first of all, let's learn about the decision maker. Okay, then we go on one slide and learn about decision maker. Okay, now let's learn about the alternatives. No, not like that. I'm gonna just try to make things pragmatic so you can actually visualize how it works. Now, let's start with a story. Say this is me, and I want to go from my home uh, to the school. Okay, and to go there, I have a route. This route, say this route number is 1, and to go from my home to school, I need something. I can walk, I can use a bicycle. I mean, I'm talking about mode. I need a mode to go from my home to my school. So I need a mode, right? Say the available modes are car or the bus, right? But as I have told you earlier, that I can actually go by bicycling or walking, but for the sake of the example, we're going to only focus on these two alternatives or modes. So it is car or bus. Now, how I'm going to choose whether I'm going to use car or whether I'm going to use bus. Now, here comes the attributes of these alternatives. Now, what are the attributes? The attributes are the characteristics that defines them, that defines the car and the bus, right? So if I take the car, there will be some time I need to spend, and there is some time or cost I need to also put in. Same goes for the bus. So if I use the bus, I need to spend some time on the bus, and I need to uh, spend my money to travel by the bus. So this is in simple term, a model or a story we're looking at, that there is me who has a need to go from home to school for a work, and to go from home to school I have some modes, and we're calling those modes some alternatives, and the alternatives are two here, car or the bus. And the way I'm choosing the alternative is based on some attributes that actually defines these alternatives. So here we have learned about alternatives, we have learned about the attributes, and the person who is actually traveling, or the traveler, that is me, is the decision maker, because I am the making the decision. I am making the decision whether I want to choose from either of these two, right? So one or the two. Now, how I'm going to choose? So in that regard, let's go to the next slide. And uh, so how I'm going to choose? I'm going to choose based on those attributes. Right now, if I put on some numbers here with the attributes, so here I got the alternatives in the proportion alternatives, and here I have got the attributes. Now, if you look here, the travel time and the travel cost are given for each modes or the each alternatives. So if I travel by car, the time that I require is 10 unit, and for bus it is 15 unit. And the travel cost I need to spend, travel by car is 15 units, and for bus it is 5 units. And in total, if we sum them up just linearly, now again, I'm not taking in account the complexity of discrete choice modeling. If I just add them up, it is 25 and 20. So you can actually see that the expenditure on car is higher than the bus, right? So the expenditure on car is larger than that of the bus. So easily, if you think just rationally that I should pick bus, and yes, I should pick bus. Now here I'm saying I should, not I will, or clearly I'm gonna pick bus, because there are some things that we cannot observe. There are always some randomness there that cannot be observed. But if we just ignore the randomness, then we can actually surely say that the decision maker, will choose bus based on the attributes because bus has less expenditure than the car. And this concept of less expenditure, we call it the maximum utility thing, right? This is the maximum utility concept. Now, in maximum utility, what happens is the person or the decision maker chooses the alternative that has the best utility or best uh, value uh, that is provided by the alternative based on what the person spent. So here, the time and the money I spend, I get the best value out of bus. So the the alternative that gives me the best value out of something, out of two or three alternatives, is the alternative that I'm going to choose. So that is what maximum utility is. I want to maximize my utility. I want to get the best thing with my money and my time. So this is the concept of maximum utility. And this whole process of a person, me, has some alternatives to choose from, and I choose them based on their attributes to maximize my utility, to maximize my utility is totally the decision rule or the decision process. So I, as an individual who is the decision maker, has some alternatives to choose from, that is the car and the bus, and the alternatives have some attributes to them, that is travel time and travel cost. And I want to maximize my utility. I want to choose the best alternative of the two. So I choose the alternative that has the best utility on it. So this is the decision rule, and this is how discrete choice modeling work. And this is, in discrete choice modeling, we actually try to predict that that individual is going to choose either the car or the bus. And this is the heart and soul of discrete choice modeling. And in the further videos, we're going to talk about more into detail and the mathematics behind discrete choice modeling. Until then, goodbye.